Welcome, everyone. This is Dr. Mercola, and today we're honored to have Dr. Gerald Pollack, who's one of the really few, really expert researchers in this area of water and what it means to us, because it's such a phenomenally important component of being healthy, is having access to good, healthy, quality, high-quality water supply. So I'll let Dr. Pollack describe his academic credentials and his training. He's associated with the university, and so welcome, and Dr. Pollack, and why don't you let us know what your training credentials are?
Okay, thanks. I'm a professor at the University of Washington. I'm in the bioengineering department, and usually that department connects biology with engineering or with the basic sciences. I've been here some years, and our interest started with dealing with muscles and how muscles work. And very interesting, it became clear to me after some time that people dealing with muscles, of course, we don't really know how muscles contract, and we've been doing research for many, many years on muscles. And it struck me that most common ideas about muscle contraction don't involve water. Well, how is that possible? Water is basically, we're two-thirds water approximately, but in terms of molecules, number of molecules, we're more than 99% water molecules. 99% of the molecules are water.
In our
So
bodies, 99% of the tissue in our body is molecules.
yeah, that's right.
That's
Yeah.
astounding.
It's really astounding. People don't appreciate that. It's because the water molecule is as small as it is, and proteins, for example, are huge. So when you take the fraction of molecules that are water, it's astonishing, more than 99%. It struck me that this is really weird that people can try to think about how muscles might contract and yet ignore 99% of the molecules that make up the muscle. So those of us who know a bit about muscle, we look in the book and we see a diagram of the proteins inside the muscle, and it looks just fine and interesting and all the parts and subparts, but water is missing.
Mhm.
So I became interested in water, and we've been doing research in my laboratory at the University of Washington now for some 10 years on water. And the book that I wrote in 2001, it's called Cells, Gels, and the Engines of Life. It talks about the role of water in cell biology, and water is absolutely central. As I said, if you look at the textbook view says almost nothing about water in practically every organ in the body, and yet, as I said, we're at 99% water, so it doesn't make any sense. And what the book does is it brings to the fore the role of water. The central message of that book is if you really don't understand how water interacts with the components of the cell, you haven't a clue how the cell works. So that's what really got us started. And as I said, we've been doing research in that area now for 10 years, experimental research. And we found out much more than we ever expected to find out about water. So anyway, that's the background. My original training, if that's interesting, is bioengineering, but I deviated quite a bit from the engineering realm, and now the work is really, you might say, scientific, mostly trying to figure out in great detail the role of water in biology and also in all of nature, because it's really poorly understood. And most people think, well, water, everybody knows everything there is to know about water. Well, I was shocked to find out that most people think that that's true. And those in the field know that it's absolutely not true, that we haven't a clue how water works. We
So
really don't.
you think even in late 2010 that even at this stage that the leading edge of scientists like yourself really are still we're just the tip of the iceberg in our understanding of what the foundational basics of water comprise.
Absolutely right. At the foundational basis, we really don't understand it. We have meetings actually I organize in Vermont each year studying or discussing issues of water. And it's surprising how many new revelations and observations come to the fore. Observations that people could not have imagined in the past. So we're beginning to develop a real understanding. And in our lab, we've been focusing mainly on water structure, water organization near interfaces. Our body, of course, is filled with interfaces inside the cell. It's all proteins, nucleic acids, salts. They're all interfacing with water. And so the central question is, what happens when water interfaces with those constituents? Does it change? Does it remain the same? And this is where we've made some, I think, important discoveries.
Excellent. So what are some of the interesting highlights you've learned and really uncovered in this last 10 years of extensive investigation on this important topic?
The surprise is, as I mentioned, is what happens next to interfaces. If you read the chemistry book says, well, if you have an interface, a charged interface or a so-called hydrophilic, water-loving interface, of which most of the constituents in your cell are, the current view is that a few water molecules might actually line up and become ordered is a very secondary effect, and it's not very important for understanding of how cells function or anything functions. What we found is, to the contrary, that instead of 2 or 3 molecular layers, the ordering of water can actually amount to a few million molecular layers. In other words, the water at interfaces can order in a macroscopic way. It's a really huge amount of this kind of water. So much so that and its properties are so different that it looks like a distinct phase of water.
In human biology, where would these interfaces, where would we typically see them, and how are the interfaces important?
So you might think of the cell as a matrix of proteins. Uh, so like a grid filled with proteins and perhaps nucleic acids and others. In between, filling in the spaces and in those grids is water. So that means that there are a lot of surfaces that interact with water. So in your cells consist, I'm convinced, mainly of this kind of water that we're talking about, this kind of interfacial or ordered water. It's actually been known for many years that this is the case, but people have forgotten about it. It starts back almost 100 years. People were thinking about this, and one particular person, Gilbert Ling, was the pioneer. Gilbert came from China. He was one of the first group of people coming from China after World War II on a so-called Boxer Fellowship. And these people, they picked 3 out of all of China to come. Gilbert was one of the ones. And another one is Yang, who won the Nobel Prize in Physics. So this is a very select group. And Ling spent the better part of his career, he's now, I think, 90 or so, or early 90s, writing multiple books on water in the cell and how central and how important water is in the cell. And for me, he was a kind of mentor who set me on this track. So the point is that this idea was known for a long time. And it became more and more apparent, although people in biology and medicine have forgotten it, that water really is central to all that's going on. So your question was, where does this appear inside the cell? It appears all over. It appears next to every single interface, everything that's suspended in the water, every protein, every nucleic acid. And so this water actually becomes part of the structure. It's not independent from the structure. You can't really think of the protein as being independent from the water, if that helps. One more property of this that made it really intriguing, I should say 2 more properties. So I just told you about the fact that the water at the interfaces, the water is ordered, but there's something else. That something else is that the water is charged, and the water just beyond it is oppositely charged. So it's like a battery. So in your cells are multiple batteries with plus and minus charges separated. And the energy for doing it, just like, you have a cell phone and you have to charge your cell phone, well, you have to charge these batteries. And the question is, how are these batteries charged? And it comes from incident radiant energy, light, heat, ultraviolet. All of these coming in separate the charge. The energy that's coming in from outside create this potential energy of order and charge separation. And this potential energy fills your cells. I think it's critical to an understanding of how your cells work. So anyway, that kind of outlines the major aspects of what we found in.
So the water is able to achieve this structure, this order, with energy that obtains from the environment, typically
Exactly.
in the form of electromagnetic radiation. So what is the most significant source of the energy? Is it sunlight, or is it infrared from thermal effects, or?
It's both. Well, of course, the sun contains an array of wavelengths, including the infrared, and some of the infrared gets through. And this building of order and charge separation is very, very sensitive to infrared. So we found that if we took some artificially generated infrared from a light-emitting diode, very small amounts of this are capable of building these huge ordered, we call them exclusion zones, because they they exclude solutes, but ordered water or crystalline water, whatever you like to call it, very sensitive to infrared radiation. So partly it comes from the sun. But also, even if you're isolated from the sun, it still comes because everything generates infrared. If you're inside a building, for example, the building generates infrared. You're sitting there, you're receiving infrared from the building, from the air that's around you, from everything around. If you turned off all the lights and isolated yourself completely from any sunlight, and you turn on an infrared camera, you can get a really beautiful image. And the reason you get a beautiful image is that there's radiation, infrared radiation coming from all of those sources. So basically, it's the sun hitting the walls, and the walls re-radiate, and the re-radiation is what you receive. So where I see you sitting, if I were to turn on the infrared camera, I see a beautiful image of radiation coming from all around you, and the same from here. So it's there all the time. It's the gift of the environment.
Excellent. So I guess I'm interested in understanding, in having our listeners and viewers understand how this structure impacts on their own particular circumstances and health. Because we've all heard a lot about structured water, and actually many people who hear about it, at least in conventional circles, are relatively skeptical and doesn't even believe the concept exists, let alone that there's value to it. And and it becomes particularly important when we seek to introduce high quality water. You've told us that 99% of our body is water, and we have to obviously replenish that. We don't make it ourselves. And the real challenge that many of us have is to make sure that we have a supply of clean water, because of course we live in an industrial society and it's associated with so many contaminants. So that filtration process to clean the water supply frequently destructures the water, as I understand it. And it's a concept that is really challenging to communicate effectively to most people. So I'm hoping you can help enlighten us on that.
Well, one of the reasons that is difficult, that people often discount the possibility of any long-range, is that we're taught that in chemistry. We're taught that the water really plays a very secondary role. As I mentioned, the idea is that the structured water is only 2 or 3 molecular layers, and that's not very interesting. I think, I guess, if I were to do a bit of self-advertising, I'd direct people to the website, the lecture that you gave. The evidence is right there, and you can see the experimental evidence in a kind of context that's meant for a fairly general audience, and is possible to judge for oneself the strength of the evidence. I think the evidence is overwhelming, and I'm almost done with a new book, that is describing it. So it's like many concepts that, the idea 150 years ago that man could fly in a machine, of course, was completely beyond the realm of any kind of expectation. But obviously we do that every day. And a lot of similar things have happened. So I think the first step is to be open to the idea that some kinds of phenomena can happen, even though we don't really necessarily believe it from the outset. In terms of the water that we drink, this is really a complicated issue. Most of it contains all kinds of junk from the pharmaceutical companies. Also, it's chlorinated, it's fluorinated, and there's some question as to how good those particular additives might be for one's health. And so there are many kinds of waters that people can buy being sold from all over, and one really doesn't know for sure which ones are okay and which ones are not okay. One story I heard was in Asia about some place where the longevity is really, really huge, and the people drink water that's legendary for its high quality. And this stuff is kind of almost muddy looking, very thick. And the tourists come, they want to drink the water. And for the tourists, they filter it because the tourists don't want to drink the stuff that looks awful. It doesn't look pure. Everybody wants really clean water that is so transparent that we can look through it and we can be absolutely assured that this is the purest stuff on the face of the earth. Well, that's not necessarily the best stuff. So let me put it a different way. I think the water inside your cells is absolutely critical for your health. If you have a pathology, if some organ is not functioning properly, it's not only the proteins inside that organ, but it's the water inside that organ. The water is not ordered in the way it should next to the protein. So So what you want to do is you want to reestablish a kind of ordering and a kind of health. Now you can do that.
But
Yeah, go
before
ahead.
we go on, that's a really important concept. So you're saying that if you don't have properly structured water, it can actually impact these much larger protein molecules that it's next to. Is that
Absolutely. It's hard to think of protein molecules as molecules. It's actually the molecule plus the water. And people studying proteins know this, and they're beginning to understand more so. So I think it's a real mistake to consider the entity as a protein. The entity is a protein surrounded by water, by this ordered water. That's the entity we're talking about. So if you need that entity to function properly, take a muscle, for example. The muscle's not functioning. It's the protein and the water that are not functioning. You need plenty of this ordered, structured water and proteins that are in their right form in order to make the muscle function properly. So if you have muscle injury, then both are not functioning. The question is how you restore it. So classically, one way of doing it is to give infrared radiation, to give heat. Well, heat, infrared radiation, they're much the same. So what are you doing when you give heat? Well, sure, you're increasing blood supply, and that helps. But you're also building water structure. That's
interesting?
that,
Interesting.
yeah, that's the one really important implication that this infrared that we've shown in the laboratory, and you can see it in the lecture, this infrared energy really builds like gangbusters, this kind of ordering. And so if you give heat, well, of course it repairs. And I think the reason it repairs is because of the evidence that I mentioned, that it's building this ordered water. So you really want that. So heat is very effective.
Does it make any difference as to the source of the infrared? Because some therapies that involve muscle treatments and use like a jade as a source of the like a mineral rock that would emanate the infrared. Is it from your perspective? Would it matter how the infrared is generated?
I can't comment on the jade because I'm not so familiar with it. But it really, what it boils down to is wavelength.
Mhm.
Now, if it emits the right wavelength, then it's going to do an effective job, and if it doesn't, then it won't. So we are studying the wavelengths, and the wavelength of 3 micrometers, which is a little bit beyond the visual spectral range. 3 micrometers is very, very effective, and it's been known that water absorbs at 3 micrometers. So if that jade is emitting at 3 micrometers, then we're pretty sure that it's going to be very effective. Uh,
Interesting. Okay.
Everything we've learned so far, what really matters is the wavelength that's been, and the 3 microns comes from the sun also. You get it from the sun, you can get it from radiation from the walls. Even your radiation, which is centered at about 9 micrometers, but it's a broad range of wavelength, and so 3 microns is included in that. So a person being near you generating infrared energy can actually be contributing to your health in a physical way.
Hmm, interesting. Maybe that has some of the explanation for the hands-on healing that we hear so much of.
It might well, absolutely, it could be. Yeah, I know there's a lot of skepticism about that, but from a physical point of view, it's entirely possible.
Okay. Terrific. So, well, are there any other implications? That is really fascinating that the transferring energy through the infrared at the at three micron level could facilitate muscle healing and repair. I mean, it's a novel concept that I haven't been exposed to before, but it makes perfect sense.
It makes sense because people have been using heat for years. And okay, and another one is light.
Hmm.
So I mentioned to you that it's not just infrared, which corresponds to heat, but also light in the visible range, and also ultraviolet and near infrared that builds these ordered water zones. And so, again, it's been known that light therapy has been used for a long time to cure or remedy various maladies, for example, depression, and also jaundice, bilirubin. So again, something that's been known for many years. We're now beginning to develop a scientific understanding of why they actually work.
Terrific. Yeah, and of course the ultraviolet section, specifically ultraviolet B radiation, can help us form vitamin D, which is so essential to human health.
Yeah.
Um, and then thank you for helping us understand the importance of structured water inside our own bodies and the application of infrared and other energies to restructure that. But how about the application of drinking structured water and the importance of that? Is it how that interacts with the water that's already in our system. Is that water integrated into our tissues, or does it go some sort of transformation before it, and how does that work?
That's an open question, and my inclination at the moment is to say that if you're able to drink this kind of water, it will be good for your health. And so the question is, if the water has structure, and many of these waters do have structure, just to interject a point, at our previous meeting, water meeting about a month ago, somebody was studying water that came from healing waters that are from the Ganges, from Lourdes, and such, and showed some of the physical chemical information that was obtained on that water. And what we noticed is that water shows the same sort of signature that this structured water does. In other words, there was a particular absorption of energy at a particular wavelength that's absolutely characteristic of the structured water. It appeared very close to the same wavelength in those waters. And that makes me think that there's really a good possibility that the water really has the capability of retaining that structure over long times. Another observation is some colleagues have been charging water droplets, and probably the charge in the water droplets is stored in terms of structure. And that charge is retained for many, many days. They tried up to 4 days, and they were able to see the charge retained almost completely. And we've seen similar things in the laboratory. So it looks like if the water does contain structure, then that structure might be preserved for a long time. And therefore, it's possible that if you can get water that has the structure, it might be good for your health. Now, a second issue is when you swallow it, what happens? So, it goes into your stomach, there's stomach acid, and before it's absorbed into your intestines, the question is, isn't it likely that it's going to get broken down into ordinary water? That question isn't answered yet. It's something that needs to be studied. But this water stays together. It's a water, for example, if you eat Jello, Jello is just filled with this kind of water. It all sticks together. That's the reason why the water doesn't dribble out of the Jello, is because it sticks together in this liquid crystalline structured fashion. And so it's possible that when you swallow the water, let's say water that does contain this kind of structure, it might actually be that the structured water is preserved. So if this structure is then absorbed into your intestines, then it's possible that it can be retained all the way into your cells. So it's also possible that it's the charge that really matters. So this structured water contains charge, negative charge usually, and it's possible that what you're really doing is absorbing the negative charge, and that negative charge is critical for building the kind of structure. So that's another possible route. I'm sorry, I'm giving you a long-winded
Oh, no,
kind of
no.
answer, but
I know there's not an easy and simple answer. I thank you for expanding on the possibilities.
yeah, well, that's the route, and I think this is what needs to be studied. And we're hopeful that in the future, we're working mainly right now on the groundwork, basic chemistry and physics of what goes on. The next step is to apply it to medicine, and this is a really important frontier, because knowing what we know about structured water, knowing that it's inside all your cells, there's a link and a scientific foundation that's forming on which we can build. So we can then project from that foundation what the impact might be on health. And this is a really open question. The point I was making before is that traditional kinds of therapies like heat and light, and also good drinking water, all fall naturally into this kind of paradigm. It could be understood in terms of this new way of thinking.
Are,
So
are there any environmental variables that would tend to destructure the water? I could think of one like heat. If you had structured water and you started to heat it to the point where it was boiling, that would seem to me to be state destabilizing. But I wonder if that is an issue, or are there any other variables that might destructure it more quickly?
well, you think that boiling might actually destructure it, but it's not so clear. Boiling forms bubbles, and even at lower than boiling temperatures, bubbles tend to form. The question, what's the structure of a bubble? We have evidence that the bubble actually consists of this kind of ordered water that surrounds the bubble. When the bubble rises, you see a cap that is on top of the surface. The question is, what's that cap made of? It's got to be some kind of water, because that's all there is. And we think that this kind of cap, or the envelope of the bubble contains structure. So when you heat the water, or when you boil the water, it's not necessarily true that you're losing structure. You might be gaining structure
Wow.
in that way. And that's something that we're exploring now, trying to find out. So in terms of heating, I'm not so sure
Well,
that it's
well,
true.
thank you for challenging some basic concepts, and I'll throw another few concepts at you, and be really interested in
Sure.
your point. Well, there's two primary ways to filter water. One is carbon filtration, the other is reverse osmosis, and the distillation. But the downside to distillation and reverse osmosis is it tends to destructure the water. At least that's what most people believe. And I'm wondering if that's something that you find consistent, or are we flawed in our thinking in that area also?
The process of reverse osmosis is a bit less clear than people think. First of all, as you know, it's a horribly energy-consuming kind of process, and so it's practical mainly in those areas where they have a lot of energy and not very much drinking water. For example, some places, Saudi Arabia depends on it completely. So I'm not sure about that. A lot of research is going on exactly how it works. In terms of distillation, that's not clear either because no, nobody knows. Okay, so let me give you this as an example. Um, if you go out, if you take a cup of coffee, just pour a very hot cup of coffee and go outside. Okay, so what do? You see the vapor, right? Now, what does that mean in terms of evaporation and what's going on? Well, if it's individual molecules of water that are evaporating, you can't see individual molecules, right? But you see the vapor coming right from the surface of the water. It means that the vapor has little particles or droplets or whatever that have to be above a certain size. Now, we know that the size we're talking about is roughly equivalent at minimum to the wavelength of light. So the wavelength of light is about 0.5 micrometers, is half a micron. So probably these droplets are 1, 5, 10 microns. Now, a droplet that you can see that's 1 micrometer contains roughly 10 to the 10th water molecules. It's like 1,000 billion water molecules in one of these droplets that's rising from your hot coffee. Well, think about it. The current view of evaporation is it occurs one molecule at a time, in which case your assertion or hypothesis that all the structure would be lost may not be true. It's not so clear whether it's lost or not because these vapor droplets that are actually seen, not what the textbook says, but what you actually see with your own eyes as the coffee or tea or even hot water is evaporating, they consist of very large clusters of some kind of water. And as I said, we have preliminary evidence that kind of water that's being evaporated contains some kind of ordered water as an envelope that surrounds them. Whether that's lost when it cools or not lost, it remains to be seen. But this is a topic for future research. I wouldn't say that the structure is lost or that the structure is gained. I'd say it's an open question. Not sure.
Well, good. I mean, it's interesting to know because many so-called experts in this area really are firmly convinced that that's what occurs in this type of filtration. That's why I thought I'd ask you. So the counter side of that is to reintroduce structure into water, and there's some approaches. I mean, and I definitely appreciate your scientific perspective on this because from my understanding, what people have told me, one simple way that one can reintroduce structure is to lower the temperature to about 39 degrees. The temperature you typically find in a refrigerator will provide some type of order because I believe as water freezes, it tends to obtain a more structured pattern as it tends to transition into ice.
We
So,
do find that. Yeah. Sorry. Go ahead.
so I'm wondering if that's one way. And then other is to create a vortex, which is what typically happens in nature. And how can that impact? And if vortexing does improve the structure, are there any parameters that one could apply to optimize it for the structure?
Yeah, okay, very good question. Uh, the first one is on temperature and 39 degrees. When you said 39 degrees, my first thought is, hey, that's warm because we think in terms of centigrade, not
Right, right.
Fahrenheit. But I understand what you're talking about. So you cool it. Well, we found that at 39 degrees, which I guess would be about 10 degrees centigrade,
Yeah.
something like that, we find that structures increased. We're studying right now the effects of temperature on the water structure that we see next to these hydrophilic surfaces. And it does look as though when you reduce the temperature, this area of structure increases. In fact, we think we're studying the possibility right now that the structured water is actually an intermediate between water and ice. It's possible that the real structure of this structured water, if you will, it is very much like ice, not quite, but almost. And so it could be that when you begin to reduce the temperature of the water, the first thing you do is increase the amount of structured water. And as you increase it more and more, that finally turns into ice as you do that. So I think that that's going in the right direction. That's correct. The other thing is vortex, what happens during vortices. And that was actually the subject of, I'm not sure how many of your listeners know Victor Schauberger. He
Right.
was a,
Yes.
yeah, sure.
Who's widely recognized as one of the leaders in this area.
Right, absolutely. It's also used in homeopathy, as you know. You take the water and you succuss, and the succussion is a bit like a vortex because you're shaking it and introducing agitation to it. So there may be a similarity to the vortices that occur. So if you think of a vortex, what happens? Well, the vortex is a kind of a mechanical perturbation or agitation. And probably it builds bubbles, little air bubbles that are deeply involved or enveloped into the vortex. And if these bubbles, just like droplets, if they contain an envelope of structured water, then vortexing would be a very powerful way of increasing structure. So I think that is another way of increasing. So both those ideas that you talked about, reducing the temperature and vortexing, probably do lead to more water temperature.
Are there any parameters around the vortexing? So it's just the length of time. So if you were to take a bottle in a circular jar, because it's hard to vortex in a square, but if you create a vortex, I mean, if to do it for 30 seconds, a minute, 5 minutes, 30 minutes, is there an ideal time to impart the structure to the water?
I really wish I could comment on that, but
Okay.
we haven't done it, and so I hesitate to
Okay. So
hazard a
it's just
guess.
speculation.
Yeah, sure.
Curiosity. And then I'm wondering if you have developed any metaphors or analogies that are useful to communicate the concept of structured water. Some that I've heard in the past, and I'm not quite certain of the specifics, so that it may break down, but is comparing the carbon structure in graphite or lead of a pencil as opposed to a diamond, even though it's technically the same carbon atom, it's the structure of it that makes the difference. I'm wondering if you have any similar analogies or metaphors that might help people better understand structure.
I do. I think the carbon is a really good one. So if you look at the structure of graphite or graphene, for which a Nobel Prize was just given, it's a hexagonal kind of structure. And ice also has a hexagonal element in it. And so the structure of graphene or graphite is actually similar to the structure that we're proposing. This is a honeycomb sheet structure. And we're proposing, and this will be in the book that should be ready in about 6 months, proposing that the structure of the structured water is not simply dipoles, as we had been discussing for a long time, but the dipole structure doesn't really work because dipoles are not charged. And as I mentioned, this kind of structured water is charged. And so the dipoles don't really work. And so we've been searching for a few years to try to find the correct structure. And so far, the evidence is pointing to a structure that's very much like graphene, very much like an array of a hexagonal array. Now, you point to carbon. Of course, carbon appears in many different forms. There's a diamond, et cetera. And the water is the same. So you think of water now as having three phases, as I mentioned. This ordered or structured water is something like a different phase. There's a lot of it, and it's different from either the liquid or the solid. So it is a phase of water in the same way that graphite is a different structural form of carbon. So yeah, I think it's a good analogy that you mentioned. So there's a lot of precedent for it. There's precedent for this kind of structure, not only in carbon and its forms, but also in ice, which is obviously another form of water. So yeah.
Now, you mentioned one component of the structured water is this charge. And I'm wondering if introducing electrical forces into a water or a current into a water would help restructure it or destructure it, if you've looked at that.
Yeah, I can do both. We have looked at that. And if you put a negative electrode right next to this structured water, the structured region grows. If you put a positive electrode, it diminishes. So um, the structured water is just filled with charge, and it's not free charge. It's charges that are fixed at points in a very tight matrix, something like a semiconductor. But it can build, and the source from which it builds is water, ordinary bulk water. So if you put an electrode in, a negative electrode, right associated with this negatively charged water or negatively the structured water, the structure builds. It just adds more and more and more, and it can grow to enormous dimensions. So yeah, if you put the electrode in, it does work. It's a powerful effect.
And and what type of voltage or amperage
Well,
looking at? A small amounts?
we it's hard to answer, but we put in the experiments that we've done, it's just a matter of 5 volts or 10 volts or something like that. And we haven't studied in enough detail how much voltage you really need to put on to be effective. It needs to be done in the future. There are pilot experiments that we've done, and we haven't published them yet.
Well, I have another interesting curveball I want to throw at you. One concept that we really haven't talked about too much in our site, but I've had some exposure to for a while, is a concept called earthing, where or grounding, simple grounding, where you're walking barefoot on the earth. And the concept here is that when you connect to the earth, uh, and you actually there's a massive transfer of free electrons, which are negative. So I'm wondering if you feel that, I mean, it's kind of interesting that you mentioned that the negative current actually induces structured water. If being by grounding yourself, you're actually improving the structure of the water in your body.
Um, I would say the reverse.
Reverse?
Not exactly, no, not exactly the reverse, but let me back up a step. So I started as an electrical engineer. And as an electrical engineer, of course, we're very much interested in grounding. Everything needs to be grounded.
Right.
5 years ago, I learned that ground was not exactly ground. I learned that the Earth had a net negative charge. Perhaps some of your listeners know that. I was really astonished. It was a Russian visitor to our laboratory who was on his way out to catch the flight back to Moscow. And he started telling me about the Earth's negative charge. And I said, "You're crazy. It's impossible. It can't be." And he said, "Oh, this fellow was about 60 years old. He said when he went to middle school in Moscow, he said every student knew that the Earth was negatively charged." I said, "This is impossible because none of us ever learned that." Next day, my students brought me a copy of Feynman, you know, the famous physicist Richard Feynman, his lectures.
And he won
And
the Nobel Prize.
oh, more than Nobel Prize. I think many physicists consider him the Einstein of the second half of the 20th century, Richard Feynman. So his lectures are quite famous and used by almost every graduate student in physics in the US. So in his book, in volume 2, chapter 9, there's a chapter on the negative charge of the Earth. So, and it's very big. And so the electric field at the surface of the Earth is 100 volts per meter. It means that if you're 6 feet tall or so, your nose is 200 volts positive compared to your toes. So there's a potential difference of 200 volts from your nose to your toes. That's all around the surface of the Earth. And the reason for that is that the Earth has a net negative charge. The reason for the negative charge is, one can speculate, Feynman and others have speculated, it's due to lightning. But there's a definite negative charge on the crust of the Earth. So when you earth yourself or ground yourself, the question is, what do you do? Now, if it's really true, and I've seen the evidence, it seems to be absolutely true that the Earth is negatively charged. If you earth yourself, you're connecting yourself to a negative charge supply.
Mm-hmm.
So what does that do? Well, it would seem to me that, and of course this has to be checked out, but if you think through the logic, if the Earth is negative, if it's more negative than you are, you have negative charge that's flowing into you.
Mm-hmm.
Now, remember that the structured water has negative charge, and I said to you a moment ago that if you connect it to a negatively charged electrode, that this stuff would grow. And so if you connect yourself to the Earth, this earthing that you talked about, it's possible that the negative charge then flows into your body, into your cells, and builds up this structure, which side effect ought to be good for you. So I don't know if it works or it doesn't work. I know that some people are actually using this.
Part of it is just is skepticism, just like structured water. People aren't familiar with the concept and they think it's a bunch of hokey nonsense. And
Yeah.
don't really have the scientific understanding or the physics training to understand this. But the free electrons are one of the most powerful antioxidants around. They can really neutralize many of the free radicals and such. But I had no concept prior to our discussion that it would also improve the structured water in your body, and even not just was free structured water, but the one that's integrated into our very cellular structure. I mean, it's just really a profound understanding.
Yeah, well, I mean, this is just a speculation at the moment, but I think it needs to be studied for sure. There's a really big difference from what we think about the Earth and what really the Earth is all about. This potential difference is enormous. If you integrate the electric field from the surface of the Earth to the ionosphere, we're talking about 500,000 volts. This is a hugely charged environment, and charge, the influence of charge is actually a very minor point in current science and current scientific understanding. I think that's a mistake. And the book that I'm writing and the next two that are about to follow will discuss this in great depth. There are a lot of new things that are coming out of these concepts.
Can you enlighten us as some of the ones that the most excite you?
Is a bit premature to say, but let's just go talk about the electric field that we're talking about. So if you think about dust, for example, so we've all seen, of course, your house is dustless, I'm sure, and you've never seen dust in your environment. But our house is not that way. We do have dust, and when the sunshine and it beams through our window, and we look at it, we can see the dust particles in the air. And I think many people have seen these dust particles. They dance around. So if you think about it for a moment, if you think about it, dust is heavier than air, right? It consists of particles. It could be skin, the pieces of skin and hair and what have you. Now, if they're heavier than air, they're subjected to the forces of gravity, and they should fall down to the surface of the earth. And of course, they do fall to some extent. You can see them gathering on your furniture, but that may also be electrostatic. But if you look directly at these particles of dust in the air, they're not just steadily descending like rain. They're bouncing up and down. And they'll bounce down, they'll bounce up, they'll bounce to the side. And a dust particle next to the one you're looking at will bounce in a completely different way. The one you're looking at may be going downward, and the one next to it, right next to it, is going upward. And it may then turn left, turn right, and go in its random kind of walk. That's what the particles are seeing. Now, why? We expect that they ought to be pulled to the surface of the Earth, but they're not. So one thing that you might think of is charge. If the Earth bears a negative charge, then anything that has a negative charge will be repelled from the surface of the Earth, right? So a piece of dust will be repelled from the surface of the Earth. So it wouldn't necessarily be pulled down. It might be deflected upward from the surface of the Earth because opposite charges repel one another. So this is a kind of the general idea of one of the concepts that has emerged from this, that the charge on the surface of the Earth is very important. There are many more that we're thinking about, but maybe are premature to discuss until they're all worked out. We're trying to learn more about magnetism and what that does, trying to find out how these charges influence weather. Clouds, for example. Okay, this is another example. Clouds consist of droplets, little droplets that stick together. And the question is, if you have a blue sky, if you have a nice day out there and you look up and you can see these white puffy clouds, this goes against all our intuition, because if the cloud consists of little droplets, droplets have the same charge, they should repel each other. But if they repel each other, that means the droplets should be scattered all over the sky. But that's contrary to everything you see when you look up at the blue sky, because you see the water droplets clinging, coming together. But if they have the same charge, they should repel each other, not come together. But they come together. You can see it if you just look up. And so, again, the effective charge must have an important impact on weather and weather patterns. As I said, we're talking about 500,000 volts from the surface of the Earth up to the ionosphere. And current ways of looking at weather completely ignore this sort of thing, almost completely. So I think there's got to be a revamping of knowledge and understanding.
Well, I want to go back to the structured water a little bit because
Okay.
it occurs to me that I kind of made some assumptions that many of our viewers or listeners may not appreciate, and that is that the benefits of structured water. I mean, it's become. I mean, it's obvious to me and many others. That's a good thing that structured imposing additional structure into your own tissue or drinking structured water to improve it would be something beneficial and something we should strive for. But I'm wondering if you could provide your perspective on the benefits of this, or why this is something we may want to have more of in our life.
We may want to have more of this in our lives because it just builds and adds to may build and add to the structure that we already have in our cells. This structure is absolutely critical. When we die, all of the structure is lost. Being alive is really the same, perhaps, as saying that we're filled with this kind of water. Every living being, even non-living beings, even gels, for example, and colloids, they all contain structured water. But for us to live, we need to have this kind of water. And this water, as I mentioned, it has potential energy because it has order, which is a kind of potential energy, and it has charge separation, which is like any battery. We have these batteries inside of us, and these batteries, nature has just two options. One is to not use this kind of energy, and the other is to use it. And I'm convinced from what we've seen that nature uses it. This charge separation is very critical for life. So that brings us back to the water that we drink. If this water contains structure, and if this structure is retained, and if we get it into our bodies and it's distributed, then this kind of water can be very, very important for our well-being and our health.
Okay.
It's an area that needs to be studied. It's an area that needs to be pursued. It could be a very simple way of improving human health, a step function increase in longevity and in health, if it's true that this kind of water is really an improvement. So what we need to do is figure out what kinds of water contain the structure. Is the structure really retained after we drink it? And if so, then this is a wonderful increment of advance on improving human health and longevity.
Okay, so
very important.
As a scientist who studied this for 10 years, over 10 years, there's no definitive proof at this point, but from everything you've studied and learned, it's a strong suggestion that the science is supporting that this is a beneficial thing, and that we need more studies to confirm this. But from your perspective, it doesn't seem to have any downsides.
I don't see any downsides. I mean, I'm certainly not a medical expert. I can't comment on that, but there's enough anecdotal evidence about cultures that use water that's very close to spring water. And a lot of people live for a very long time, and there's correlation. That's not evidence, but it's certainly suggestive. And everything we know is suggestive that the more of this structure you have in your body, and you could get it by drinking, that would be certainly one way of getting it. The more structure you have, the better off you are. That's what we...
Have you ever looked at waters from different types of sources? It's my understanding that some of the healthiest water is from mountain springs, fresh mountain spring water. So I wonder if you looked at that versus lake water, river water. Or
I actually haven't, but my colleague from Russia, Vladimir Vyakov, has been looking at waters for human health in Russia, around Moscow area, and he goes around searching, and he has certain tests that he applies to the water to see the quality of the water. And this is the water he drinks himself. It's the water that's used in a very, very popular clinic in Russia that has more patients than it can actually accommodate, including some very highly placed patients, very effective therapies. And he uses it also in his garden. Mm-hmm. And so I don't know if you know the Russian tradition. Russians like to have dachas outside their apartment inside the city. And so there'd be a garden where they'd grow vegetables, and his is a couple of hours away from Moscow. And I had the opportunity to visit his place, and it's packed with people with little cabins and gardens. And all the Russians go there on the weekends and plant their vegetables in the springtime and harvest them in the early fall. And many of these families have been around there for many generations. They're growing potatoes and cucumbers and whatever. And Vladimir and his family are relatively new to that, but their plants are 1/3 taller than the plants of all their neighbors. Now, they don't have a noticeably greener thumb than any of those, but they're plants. So why are the plants taller? Well, a possibility is that the plants are taller because he uses this kind of water, the kind of plant growth that he gets by using this would be very much analogous to the kinds of advantages that we might have in drinking that kind of water. So yeah, I think there's a really good chance. As I said, the evidence is not in, but every bone in my body is suggesting that this is going to be a very important aspect of medicine in the future and of human health, to really understand the water, understand the structure, and to understand how this structure is centrally important to our health.
What type of water was Vladimir using? Was it from a mountain spring, or how do you identify the high quality water?
Well, he has some tests that he uses. I think these tests involve fluorescence, he's looking for high energy electrons, and he hasn't described in great detail the test, but he's looking for basically what you were mentioning before about the negative charges that are so important and also so central to the water structure that I've been talking about. And he selects the one with the highest, the largest concentration of these highly energetic electrons.
Do you know if he has any plans of commercializing that type of assay?
I can't comment on.
Okay, that'd be interesting.
I'm not sure.
Sounds like there'd be a good market for that.
Well, like me, Vladimir is a person who is absolutely dedicated to science. He spends all his time doing that.
Well, the next time you see him, if you could ask him, it'd be great. Hey, now you also mentioned magnetism. From your understanding, can magnetism, like the North Pole, induce, or even the South Pole, produce any structure or destabilize a structure by exposing water to it?
I wish we could speak in 6 months from now, because we're starting to study the effects of magnets on water. It's elusive. Sometimes we find nothing, and sometimes we find something. So we've seen some effects of magnets on certain aspects of the water. It's not repeatable enough. There's a Japanese guy who's published some work on this. His name is Ko Higashitani, about 10 years ago, and he was studying colloidal solutions. And just at our last water meeting in Vermont, he presented very convincing stories, convincing results obtained in many, many different experiments, showing fairly consistent results of magnetic fields on all aspects of water. So I think there's something going on there, but it's not really clear yet what's going on.
A form of a therapy or not therapy, but a modification of water would be alkaline water. And there's most of the units that incorporate this. I'm sure you're familiar with it. They are somewhat costly, but many people are using it for supposed health benefits. And I'm not convinced that it's useful, and most of the people, experts I know, aren't convinced either. But I'm wondering, as a pure scientist, if you have looked at it or any thoughts on it.
We haven't looked at it, and I'd have to know exactly how alkaline water is defined. I guess it's defined in terms of pH, but what really matters is I think based on our research, is not necessarily the alkalinity or acidity, but how much structure there is. Now, if as a byproduct of structure, if the water is either alkaline or acidic, that could be one thing, but I'm not so sure that this is necessarily the case. So I don't really have a comment on that. We haven't studied it. We haven't. Any real. Yeah.
I really appreciate all the work you've done and all the explanation you provided us in helping understand there's a really important concept of structure and really some fairly foundational principles that we can easily apply to help us improve the structure in the water we have, but also the structure in our bodies, and that. There's some simple approaches that can be profoundly useful and really to enlighten us and sensitize us to the fact that to be aware, because this is an emerging area, and it's likely that in the future, perhaps even the not too distant future, there's going to be discoveries coming that really support this and provide very specific applications on how we can improve the structure in our own water, in our own body rather.